Alrighty, sorry about that. So I'm giving this talk next month at UtahJS in San Antonio. It's write test, not too many, mostly integration. So yeah, hopefully this is a good experience for everybody. And if you have any feedback for me, I'd appreciate it because I want to do my best. So before we start, though, I'd like to invite everybody who's physically able to please stand. Yeah. All right, so we're going to do air squats together. Get our blood pumping so that you can wake up. So put your arms out in front of you like this. Squat down and come back up. That's an air squat. We'll do 12 together. Ready? 1. Count out loud. 2, 3. Am I going too fast? 4. Just kidding. 5, 6, 7. You're doing so awesome. 6. No, just kidding. 8, 9. 10. Oh man, you're fast. 11 and 12. Awesome. Okay, before you sit down, turn to the person next to you, shake their hands, and thank them for coming. All right. Cool. I wanted to shake all your hands individually and thank you each individually for coming, but I figured maybe that would. Yeah. Do 12 squats individually. No. So now you got your exercise for the day, and tomorrow you're going to do your squats again, right? So this is good. Okay, so I like to start my talks out with expectations so that you can tune out if you want to, if it's not what you want. So this is dissecting Guillermo's tweet, and I'm going to show you what that tweet is here in just a second. I'm going to talk high-level principles of testing. So I will talk about JavaScript-specific stuff in my examples, but the principles that we talked about apply to testing for regardless of the language. What? Sorry? And then this is also opinionated. It's full of opinions that I've developed over the years that I've been programming and the experience that I've had talking with other people. Hopefully it's not boring. And I haven't thought about the other things that it's not. So if you have suggestions on what I could put in here, let me know. Okay, cool. So this is the infamous more than famous tweet. Anybody know what reference I'm making more than famous? Yeah, thank you. The three amigos, anyone? Okay, well that's what infamous is. It's more than famous. So Guillermo Rauch, he created Socket.io, if you're familiar with that. He's also the CEO of Zeit, which created now.sh. He's like just the coolest person ever. But anyway, he tweeted this back in December of last year, so over a year ago now. Last year. And I thought it was really interesting. Write tests, not too many, mostly integration. Does anybody know what that's kind of referencing? Eat food, not too much, mostly plants. So he's kind of playing off of that. So I thought it was so interesting that I wanted to write a blog post about it. And so that's what this is. So if you ever see the pineapple with sunglasses, that's my blog post. And that's what this talk is about. We're going to dissect this a little bit and talk about each one of these very short sentences. So write tests. How many people here write tests for their applications? That is still not 100%, but it is certainly better than it was even like 3 years ago, especially in the JavaScript ecosystem. Testing has become more and more important over time. Maybe one day everybody will write tests because everybody in an application that you really care about its stability, you should probably be writing tests because the alternative is to manually test things, and that's no fun. The other alternative is to get a call at 2 a.m. when the servers are down or like the checkout button isn't working, freaking out trying to fix this bug that would have been caught by a test. So yeah, we definitely want to write tests. I think that like the most important part of testing, or like the reason that we test, is all about confidence. How much confidence does a test give you that your application is working according to the way that you want it to? And so you can accomplish that really well by like going through the application manually and just clicking on all the buttons and everything. Like I can develop a really great sense of confidence that I can add items to my cart and I can check out by just like manually going through it. But I'm not going to do that every single time I make a change. That especially as the team grows and the app grows, the permutations of all the different things that you can do in your application just becomes infinite. And there's no way you're going to have the resources to manually test all of those things. So writing those tests to increase the confidence that you're shipping what you think you're shipping is, I think, really important. So another thing that you can do outside of writing tests to increase that confidence is by using static code analyzing tools like ESLint to check your code, make sure that it's like you're not using a variable that's not defined, or like there are a whole bunch. You're not trying to import something from a file that doesn't actually exist, or it's not exporting that thing you're importing. So there are a lot of really awesome things you can do with ESLint. And then if you want to really improve your confidence, you can use a static type checker like TypeScript or Flow. And those will really, they kind of improve your confidence, but also like just do away with a whole category of problems. So you're not going to call like toLocalString on, or like, I don't know, call some method like .map on a string or on a number or something like that. So yeah, static type checkers can really help. But even with ESLint, like a really great ESLint setup, and with a static type checker like Flow, you're still not going to catch all of the bugs, because those won't give you any confidence in regard to like your business logic, making sure that you're charging the user $5 instead of $20 for a particular product or whatever. So yes, definitely we should be writing tests. So the next thing he says is not too many. So how many people here strive for 100% code coverage, like all the time? Nobody. Well, just kidding. I actually have been on a couple teams and seen a lot of teams that, actually I should ask first, who knows what I mean when I say 100% code coverage? Okay, so most of you. So I'll just quickly explain code coverage. Code coverage is a metric that measures how much of your code is being run when your tests are running. And so like I could have a sum function and an add function, and I have a test that calls the sum function, those are like the same thing, sum and subtract. And I have a test that runs the sum function but doesn't run the subtract function. I now have 50% code coverage because only half of my functions are being run. The other is not being run during my tests. And so to get 100%, I'd write a test also for the subtract function, or rather a test that runs the subtract function. And so in your code base, you can have many functions, many lines of code, and so code coverage report is able to take to measure what lines of code are being run while your tests are running, and then give you a report of those lines. So you can work your way up to ensuring that at least all of this code runs. Whether or not it's actually doing what it's supposed to be doing is a whole different story. Whether it handles the proper data inputs and things, that's a whole different thing. But code coverage can at least tell you that at some point in time during the test running, this line of code ran. And so some teams will enforce a code coverage threshold on your code base to say you can never drop below 50% code coverage. If you add code to the project and it drops the code coverage report below that, then you have to add some more tests to make sure you're testing the code that you added, which is great. But I have seen some teams that take that to an extreme and say every single line in our code base must be run to be able to get into master or whatever. And that is not like entirely a bad thing. Like the intention is good, but the problem is with an application, there are a lot of branches of code, and when you're focusing on 100% code coverage, you can you wind up doing some really weird things to make sure that you cover all the edge cases that your application has to cover, and you often wind up writing special unique tests that kind of test implementation details just so that you can get this weird edge case, and that kind of diverts your attention away from other work that's maybe more important. And so there's not really a magic number for how much of your code base should be covered, like what percent. I say 70% just because that seems like pretty good, but like depending on how fast you need to ship stuff and how important it is that things don't break in your application ever, that number could be wildly different. But yeah, I think like another thing on the testing implementation details, a good way to know whether you're testing implementation details of your code is if when you refactor or when you change code to be like something different, but it actually does exactly the same thing. When you do that, if it breaks any of your tests, then your test was testing an implementation detail. So if the thing is still working exactly the same, it just does it a different way, and your test breaks, then you're testing implementation details. So you really want to avoid that because those kinds of tests can really slow your team down. So as a side note, I do a lot of open source stuff. I have over 100 packages published to NPM. And on almost all of those, I have 100% code coverage. So like I said, this is all kind of a really situational kind of thing. So it's okay to have 100% code coverage on a really small project that has very few branches, or it also these libraries are used in many different applications, and so if these break, then many applications break. So it's really important that these things don't break, and so it's worth the extra effort to make sure that you get code coverage on that. So it's not like an absolute rule, it's more like a guideline, follow the codes kind of thing. So yeah, not too many. And the last bit is mostly integration. So how many people know what I'm talking about when I say integration testing? Okay, how many people have heard of the testing pyramid? Okay, got a couple. So let me just show you a quick picture of the testing pyramid. So this is from a slide from a workshop that I have about testing. And it's actually two images overlaid because I didn't like what this guy called his levels in the pyramid. But I did like these cool little things here. They're illustrative. So this is the testing pyramid. There are a lot of different ways that you can, or a lot of different forms of testing, automated testing. So you have regression testing and, well, here we have end-to-end testing, integration, unit testing. You also have security testing and penetration testing, security testing, user acceptance testing. There are lots of different forms of testing. But normally when we're talking about automated testing, we're talking about one of these three tiers of testing. So a unit test would be like testing our add function to ensure that it's adding two numbers together properly. That would be a unit test. They're normally really easy to write. They run really fast. And so that's why down here you see the bunny. It's running fast, and it's also fast to write. It's also really cheap to run and write. So unit testing is often fills most of what what we know as testing. When we write our tests, they're mostly unit tests, at least most in the community, as far as I've seen. Integration testing is a level above that, where instead of just testing the add function, you might be testing when I click increase the quantity in my shopping cart. That's going to maybe call the add function. I don't care that it's calling the add function, but all that I care about is when I click on the increase the quantity, that quantity is increased by 1 or whatever. And so it's kind of taking a couple of these units, the add function and the shopping cart function, whatever, and it's putting them together in their pieces in an integrated way to make sure that they work together properly. And I don't really care what those pieces are. I just care that that piece of the entire experience works as I expect it to. So those ones are a little bit harder to write because it can sometimes require a little bit more setup. You have to make sure that you have a shopping cart that exists and you have items in that cart, whatever. But they often don't cross boundaries from the front end to the back end. So you're not going to actually have a database running or anything like that. This is just on one side or the other. testing that those pieces integrate. Sometimes it can include like talking to a third-party API that you've mocked or something, making sure that it's calling that API properly or something like that. But yeah, the separation here is a little bit fuzzy. Oh, and one thing on the unit test that kind of distinguishes it is if your unit has several dependencies that it's relying on, like to do its magic. Maybe this add function is using a separate node module that's like a line long or less. I don't. Can you have less than? But anyway, it's really short, and so you want to mock that out or something like that. So I don't know. I'll talk about mocks here in a second. I think they're weird, but yeah. So unit testing is normally like really isolated to one thing. Integration integrates multiple pieces, and then end-to-end testing or E2E is when you're kind of testing an experience. So like I want to given I have this user, I want to fill their shopping cart with multiple items and then go to the checkout and make sure that the checkout processes properly. And you may like have some sort of mock set up for the credit card processing and whatever, but pretty much everything else should be the actual experience. And so as you go up the testing pyramid, the cost and the speed at which you're, the cost of running and writing these tests increases, and the speed slows down. So to run and write the tests. End-to-end tests are often a lot more tricky to write and debug, and yeah. So does that make sense? Hopefully a little bit. So yeah. So this is the testing pyramid. It's a really common thing in testing, and yeah. As you can see, integration fits in right in the middle there. Well, here's the problem with this particular testing pyramid. Something that it doesn't really show you. So we see that end-to-end, like as you move up the pyramid, like the running time and the writing time slows down. And as you move up the pyramid, it also costs more in terms of resources to write them and things. But one thing it doesn't show you is that also as you move up the pyramid, your confidence quotient increases. And so like the bang for your buck. So one end-to-end test can give you just as much confidence as like 1,000 unit tests. So it's like it's not just as simple as this. So somebody once criticized my position on this and said that I am the ice cream cone. So I think I need to get a new graphic or something. But as if you can see that, it's like I like ice cream, and so I'm cool with that. So I kind of like the integration testing, and that's why I'm on the side of mostly integration. Not to say that like you never use unit tests or you never do end-to-end tests, but integration strikes a really good balance of confidence for effort, and so I think that's where we should focus most of our time when we're writing tests for our applications. So it's a really good balance between speed and expense. And on top of that, the tools that we're using to write tests these days have improved significantly. So like this expense and the speed are starting to become less of an issue as you move up the pyramid. But the confidence coefficient is never going to go away. You will always get more confidence with an integration test than a unit test. So no, that's the end. So just one other thing. So like on this testing pyramid, we have these different levels. So one thing that people ask me a lot when I say, hey, we should be writing more integration tests is, okay, how do I stop writing unit tests and focus more on integration tests? And the way that you do that is pretty much stop mocking so much stuff. So maybe I should have an example here or something. But if you have, like often I'll see in, actually, how many people here are React, like code React stuff? Okay, most people, Angular? Okay, couple, Ember? Aurelia? No, just kidding. I'm not just kidding. I'm sure Aurelia is great. Svelte? Anybody do Svelte? Not for work? Oh, you're living on the edge, man. Svelte is really impressive. Anyway, with React, how many people know what I mean when I say shallow rendering? Okay, just a handful of you. So with React, when you're writing a test, like the whole idea behind React is everything's a component. And so you're going to render your component and make sure that whatever's rendered is what you expect it to render, and you can interact with it and stuff. Well, React has this fancy thing called shallow rendering, and you can do this with the enzyme testing tool with React, where you render a component, and it will render everything until it finds another composite component. That's a component that's not like a DOM node, but like a custom component. Once it hits one of those, it stops, and it just gives you information about what the component is and what props it was passed. And this is in an effort to write an actual unit test. So you're only testing the component that you care about, and the rest of the render tree below that component that it hit as it was rendering is just an implementation detail. So that is a form of mocking. And a mock is just like or this is also called like a test double or a stub. There are like a million names of this for this thing. But it basically is an imaginary version of the thing that would actually happen in the application. Like you'd mock a credit card processor or something. So when you shallow render and it says, okay, I'll stop, and this is what I would have rendered. It's this component with these props. And then you can make assertions like, when I render this with username equals Kent, then it's going to render the username display component and pass it the prop Kent. And you can make that assertion, but that doesn't give you a whole lot of confidence that what the username display component is going to render as a nice, like, beautiful Kent word, whatever, to the user. So it gives you confidence that, yes, indeed, I am rendering the username display component, but it doesn't give you any confidence that what the user is going to see is what you want them to see. And so by doing this mock, you lose a whole lot of confidence. And so with React, I pretty much say never, ever, ever, ever shallow render. There's like, I have never seen a case where it's necessary to use shallow rendering with testing. If you do want to mock something, because there are some situations where you might want to, like with animations or something like that, I've done this. You just use like other mocking mechanisms. The JS testing framework has really awesome mocking capabilities. But other than that, there's like, yeah, you never want to do that. And the more you mock, the more unit tests that you're writing, the less confidence that you're going to get out of your tests. The other thing is you can write tests that are higher up in your application tree. So you could actually render your app component, like the top level component, render that as part of your test, and make sure that like you can click around on buttons and stuff, all like simulating and everything like that. That actually can be a really awesome integration test for some things. So yeah, just lowering the amount of things that you're mocking and using kind of higher level components, not just like React components, but higher level functions that are integrating a lot of pieces together. Focusing your effort around that can help you focus on writing more integration tests and fewer unit tests. And that's pretty much it that I had for our little chat. It wasn't quite like 45 minutes like I think it was supposed to be. I don't have resources yet, so I'm going to get those later. If you want resources about this, then come ask me later. But yeah, that's it for me. So thank you so much. Does anyone have any questions I should have asked? Did anybody think I did just okay a little bit? Is that all right? Okay, I got a couple. All right. Yeah.
Is it possible to go through a sample test?
A sample test? Yeah. Yeah. I wish that I'd like thought about that and prepared something. I could. Well, I could write a couple right now, but they'd like be unit tests. To do like a real integration test, I'd have to have like several pieces that go together. But I could do that if anybody. Well, I wouldn't want to like. I guess I do have some time, but well, we'll see. Did you have a Cypress? Oh, Cypress, yes. I clearly have thoughts on Cypress. Cypress is amazing. So if you're for your if we look at this thing again, if we're talking about tools, you have these three tiers. For these two, Jest. Just use Jest. Only Jest. You don't need anything else. Jest is amazing.
Yes.
Yeah, so if we go to facebook.github.io/Jest, this is the Jest testing framework. It's incredible. You don't need anything else. I've used everything, and I'm telling you, this is the one that you want. So yeah, it's super, super fast. It has like crazy awesome features, and it like comes out of the box with amazing. Oh, hey, look, they put it back. This is my video on Egghead.
Here in this project, we have a module
like
called sum.js, and inside of this module,
that's kind of fun. Can I can't actually like make it bigger. Well, zoom in, I guess. I wonder if you can video. There we go. Anyway, so yes, Jest is amazing. Definitely watch use Jest for unit and integration. But for end-to-end testing, like I need to verify that a user can register, and then I need to verify that a user can go through the whole flow, add items to their cart, and check out. Like the whole shebang. Cypress is your jam. Cypress is so good. So if you haven't done much end-to-end testing and haven't felt the pain of Selenium, then you won't really get to experience the joy that is Cypress. You'll just be like, oh, this is great. Whereas if you'd actually ever tried Selenium and these other tools before, you'd be like, oh, well, this is the best we've got. That's too bad. And then you'll try Cypress and be like, oh my gosh, this is amazing. So yes, I am a big fan of Cypress and highly recommend you give it a look. Yeah.
Similar to Ghost Inspector?
Yeah, I've actually used Ghost Inspector. So I used to, have a podcast. Anybody hear of JavaScript Air before? Yeah.
I tried yeah. I did that website.
Yeah. So this is me, and maybe one day I'll start it up again. But it's got like almost 50 episodes of really interesting things. We got Brendan Ike on to open us up and close us out. So yeah, pretty cool stuff. But I used Ghost Inspector to like run on this website, make sure I never broke anything, and it caught some stuff for me. So it's kind of nice. Ghost Inspector, it has like a web interface. You just like say, okay, then navigate to javascriptair.com and then click on this thing and then verify the title is the right thing, whatever. So I used it because it was free and it was all online. I didn't have to have any sort of infrastructure. So how does it compare to Cypress? Cypress is like way more. So it's kind of hard to compare them because Ghost Inspector just does a couple of things. And Ghost Inspector is really cool. And it's all online, which is pretty neat. But Cypress, you can run it locally. It's actually like an app. So this is the app. You install it on your computer. And then it'll open up whatever URL you tell it to. And you'll see like your app right in there. And then here's where the tests are being run. And what's super cool about it is you can see what's going on. You can pull up the Chrome Dev Tools right inside the app. You can select around. If the test breaks, it'll show you exactly what step broke, and you can click on that step, and it'll show you what the page looked like at that time, which is something that you could never ever do with Cypress. It's just like with Selenium. It's mind-blowingly awesome. So yeah, Cypress is definitely a tool to look at. Just in Cypress, those are the only two tools you need. And actually, the Cypress folks will tell you that Cypress is the only tool you need because you can actually run unit and integration tests in Cypress. But I like Jest too much, so yeah. Yeah. Yeah, well, sure. Yeah, so let's see. Anybody heard of Glamorous before? Yeah, so that's me. And downshift, I'm more excited about downshift than glamorous, but not as many people know about it. If you want, something I'm really excited about, Babel plugin macros. Nobody's heard of that, have you? No. It's coming. It's going to land in Create React app. Then you'll know what that is. It's going to be so cool. Yeah, so Glamorous, it's a styling solution for React. It's pretty cool. Kind of like styled components. More of you have probably heard of styled components, except it uses objects. So here, if we look at some of my tests in here, let's see. Maybe the with props thing. So a test with, and I realize that I probably have about like 5 or 10 minutes, but I'll try to get this done. A test is just a regular JavaScript file. I actually wrote a blog post recently, but really, what is a JavaScript test? Where this will explain to you like step by step what a test even is. So if this is something that's interesting to you, just look for, but really, what is a JavaScript test? And it'll have this guy. This is why I do these like random pictures so that you recognize it. So you'll never forget the pineapple. Like, yep, there he is. And this guy is standing in the ice. I just felt cold. But yeah, so this will kind of explain where, like, in more detail what a JavaScript test even is. Yeah, it's really just a file that has some code in it, and here we define this is a test and this is what it's called, and so when it fails it tells us the test called this is the one that failed. And the way that you make a test fail is an error is thrown, and you have an assertion library that will throw errors if things aren't looking quite right. So I say, here I'm going to create this object, and then I'm going to create a mock function that keeps track of when it's called. So I can make assertions on that. So this would be like dynamic styles equals an arrow function. So basically the same thing, except this arrow function just happens to be something that keeps track of when it's called. So I can say, were you called? And it says, yes, I was. Hooray. So we have this dynamic styles function, and then I'm going to use whatever it is that I'm trying to test. So in this case, I want to make sure that when I say glamorous.div and pass it a function, and then I call with props on it, that, and then when I render the component that I'm given back, that these things are true about that rendered component. So I ensure that this dynamic styles function was called one time, and that it was called with these things. So it was called with prop A and prop B, and this other prop because that was passed here. And don't worry about the expect context, that's something else. But anyway, does that kind of give kind of an idea? So the whole idea is you set up some state, you use the API that you're trying to test, and then you do some and this I guess kind of includes that, so I'm going to render that thing. And then you do your assertions. You expect things to be a certain way. So this is a true unit test. Well, not entirely a true unit test. There are a lot of like units that this code goes into, so it's a little bit of a integration integration within itself. That's why I say like unit and integration tests are kind of loosey-goosey. But if you're not mocking things, then it's like mostly a good thing. But I do mock some things. Like sometimes it's useful to mock things, but most of the time you want to focus on it. And this is a library too, so things are a little bit different in libraries. But yeah, does that kind of help? Yeah. Sorry, which one? Oh, yeah. So that actually is part of the jest assertion library. So no, but actually in here, I show you how to write something like that. Woo. So the expect function, I pass in what the actual thing is, and then I return some utility methods that will simply throw errors when things are not correct. So we have a 2b on here. We could also have 2 have been called times, and that is going to be a function that accepts how many times we expect it to be called and make sure that it was called that many times. So yeah. Any other questions? Okay. And I'm done. Thanks, everyone. Well, yeah.